I hear someone coming down the stairs. All right. Doing favors for my wife because she is more important than you. Sorry. But I still think you're pretty cool. Okay, just making sure audio looks good. That has been my Achilles heel lately. Gotta keep an eye on that. Okay, anybody who has been watching the non-stream version of this has been quite patient. So let's do a quick intro. If you have not watched before, Hi, I'm Joe. And I am doing a stream series on transforming a NES, and in the future, hopefully some other consoles, into just plain Jane computers, because why the hell not? Because the universe is meaningless chaos. And so why not celebrate that? Yeah, so I just came back from a week-long vacation, so I'm really looking forward to getting tucked back in here, and hopefully this will be a fairly nice long stream. What have we done up to this point? We have taken a Super Mario Bros. 3 cartridge and hacked it offensively until it ran our own code. So it's doing that now. We have written code to write characters to the screen in sort of a terminal-ish way so that we can... the idea here being is that at some point we're going to try and port Microsoft Basic to the NES. Don't know if that's ever been done before, but we're going to try and do that. And then there is the curveball that I decided I'm going to take this to VCF Midwest, which is in like 2 weeks. And, you know, I seriously doubt I'm going to be able to get everything done. The aforementioned character printing stuff is done. We got that wrapped up. I had started on keyboard input, but that's about where we are. So for VCF, really doubting that, you know, we'll have a full working BASIC available there. So we'll have to talk later about what we're going to do when we get there, or what my plan of action should be for what I'm going to prep to bring into VCF. But regardless, in the meanwhile, we're working on this guy. This is a TI99 4A, which if you're not familiar with them, is a, I was going to say 8-bit microcomputer that was available in the, I want to say late 70s. It may have only been in the 80s. I don't know. I'm not a big... I think the TI99 4A is totally neat, but I don't know that much about it. So, sorry about that in advance for TI99 4A fans. Anyway, I hacked this up some time ago for various different projects, and so there are a crap ton of cut traces on the back of this, and I need to fix those up. I started doing that in a little stream before I left for vacation, but we have to wrap that up. So I'm just gonna do that real quick, and then we are going to start building some software to interface this with the NES. So I'm hoping to get fairly farish with that tonight. Fingers crossed. Anywho. Oh, let's get started. Let me switch to... This is probably the best shot for soldering. Maybe adjust this a touch. Sure. That works. And thankfully, the cat hasn't vomited on the bench, because the cat has vomited basically everywhere else in the house as we got back yesterday, so you're welcome for that, I guess. The cat says you're welcome for that. The cat cares. Okay, what do we have left to do here? I did a fair amount, but man, there's a lot of cut stuff on this board. I was almost thinking, let me just fix up the ones that are obvious. Let me see. The ones that are obvious that I still haven't fixed, which is going to be fun because there's a lot of broken shit. Now, you know what? Let's do this the fun way. The way that I was kind of thinking of originally. Yeah, let's go here. So, let me see if I can find it again. I had found on Instructables at some point, and maybe there's a better one somewhere else, but somebody had already done the keyboard matrix for TI99 4A. You know what would be a great way to proceed with this is instead of just trying to eyeball fix all the stuff that's broken here, because it's just a lot of just slashes on the board. What if let's just go ahead and scan the matrix and see what keys are and are not working, and then, you know, fix the ones that are not working. Do it that way. But yeah, so I need to find the matrix first, because I don't want to pin out the matrix myself. So TI99 4A keyboard matrix. Yeah, so I definitely found this one. This first one. So that's probably good enough. I will do some confirmation on this, but that seems like it's probably what I'm looking for. Look at that. Should be P straightforward. Let's check. I don't know. Let's choose a random key. Maybe the 1 key, which is... I wish they had these labeled by pin number, but they don't, so whatever. But let me just figure out first. I will do a sanity check with a multimeter, and then I have a ton of Raspberry Pi Picos and stuff around, so should be really easy just to make a quick matrix scanning thing and make sure the whole doodly ding works. Where am I? What am I doing? Here. Take an alligator lead with a pin on it, and wish I were sharing my monitor and this camera at the same time, but I'm not, so apologies. I don't know which is pin 1 and pin 15 on this, so I mean, I guess that's good. I guess this will tell me. So I'm just going to make the assumption that, I don't know. Let's call this one pin 1. Sure. And let's see. Oh, that's totally not going to pin 1 though, because I'm crazy. It's going to pin key. The 1 key is at pin 1, 2, 3, 4, 5, 6, 7. Yes, pin 7 and pin 8. So that's easy. So 1, 2, 3, 4, 5, 6, 7. And conveniently, I have another one of these sitting around too. That should be 8 right next to here. Yeah? Yeah, one would think. Okay. And my hardware store multimeter is right here. So let's just put that on resistance mode, and that needle should go flying up when it detects. Yeah. I'm gonna make this good for you. I'm gonna make this nice for you. You'll like it. Nope, you can't see it. Sorry. I mean, you can kinda sorta see it turning. Sure, good enough for me. So if I attach one side to one side and the other side to the other side, so now it's attached to pins 7 and 8. And is my one key right here? Yes, my one key is right here, so it does nothing. Which, yeah, it looks pretty mangled around the one key, so that was not a good sanity check. What's another good key? What's another? I should have checked what keys look least mangled on here. I don't know. Q? Q looks passable, maybe. What is Q? Q on the matrix is 8 and let's see, I think 9. No. Yes? Wait. So this was 7. Convenient, because this is called INT7. Let me make sure I'm not counting wrong. 1, 2, 3, 4, 5, 6, 7. So the row is pin 8. That's this guy, and this is 8, 9, 10. So it should be 8 and 10. Again, this is all assuming I have my wires in the right way around. But let's just assume. So if that is so, then 2 to the left of here should be 10. And let's try Q. Yes. Yes. Can you kind of see that turning there? Cool. So that hopefully mostly confirms some stuff. Is this better if I... There we go. It works. So that is correct. That is Q. This keyboard matrix pinout that I have here appears to not be a horrible liar. Very happy to hear that. And if I look at the way the pins are done on here, is it at all possible for me to have these backwards? Because if not, then I know the order of my pins and that I have it right. So if this was one, the opposite of the one I assumed, then 1, 2, 3, 4, 5, 6. Yeah, so no, I had it the right way around. Neato. So let me Sharpie the one that is 1. Do I have a Sharpie convenient? I do. Very good. This is 1. Never forget it. Cool. So that's that figured out. And now we can do microcontroller things. Yay! So I think the easiest way to go is just plug in a Pi Pico, my microcontroller of choice of late. It's fun. It's easy. It runs Python real good. Hello, Lolis. Good to see you. We are going to write a quick... Lola said, what happened to this poor thing and what is the plan? So, gonna do a quick rundown, because you deserve it for popping into chat. But I already, at the top of the stream, kind of gave a rundown. If you're not familiar with this whole thing, I am doing a streaming series to turn an NES basically back into a PC for no good reason, because it's silly. I want to run Microsoft Basic on it eventually. And right now, so I've already implemented a ROM cart that has some code on it that lets me basically print characters to the screen. And now we're working on the input part, which is where this keyboard comes into play. And this is a TI99 4A keyboard from a machine that I used to have, and then I hacked it up real horribly, so we need to fix a bunch of traces on here. But we have somebody already did the keyboard matrix for me. Thank you, whoever did this, whoever it was. I have no idea. Some mystery person. And so I am just going to use that matrix and a microcontroller real quick here just to scan through the keys and see which ones are dead so that I can more easily and quickly fix them, because that should be relatively straightforward. So, yes, let me just plug some shit in here. I need, according to this pinout, I mean, I guess I could also just count the pins on the damn thing itself. Just get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And that should work, I think. Okay, so now I have 15 wires here that I can split up and plug pretty easily into my microcontroller, assuming it wants to work for me. I'm also going to need to find a cable for it, and I don't think I have downloaded Thani and such onto this machine yet. So that may be a thing, but that's pretty fast. Let us just get this split up, and I will just jam it into the GPIOs, because they should be labeled here. And it should be that straightforward. Let's see. GPIO 0. And 1. And that is it. Then 2, 3, 4, 5. 2. Welcome to the counting show. 3. 4. 5. And then a ground, and then 6, 7, 8, 9. 6. 7. 8. And 9. And then a ground. And then 10, 11, 12, 13. Another group 4. Cool. Keeping it regular. Appreciate your Raspberry Pi Foundation. 2. 3. 4. Mind you, I'm not going to use a microcontroller for the final design. Just out of personal preference. I could. It would probably be way faster to implement, but I'm not going to, because it's not as fun. Okay, a ground and then 14, and we are done wiring that up. So there we go. There's our test thingy. Now I just need to find a USB cable, get Thani installed, kill my soldering iron for a second, and look at the chat where Lawless had put another message, and I hadn't checked it, and I would much love to, but Lawless said, I know about the BASIC, but I'm curious about the keyboard. How do you plan to connect it? Again, I've mentioned this before in the past to give you incentive, if you haven't, to go back and look at past videos if you want to waste hours and hours of your life. But functionally, what I'm going to do is, NES controllers are super simple. They basically have a output pin that you can raise or lower that lets you trigger the latch pin on a shift register chip, and what that does is it's connected to 8 different inputs. In the case of the NES controller, it's buttons, and so when you raise the latch input, or when you assert it, it captures the value of all of those buttons and stores them internally, and then there is another input to the chip that you can toggle on. Well, you actually can't manually toggle it on and off, but you can effectively toggle it on and off by writing to a register, actually reading from a register, and every time you read from that register, it raises and lowers that pin, which causes the shift register to shift the next thing in until it's run out of data. But the NES doesn't know that anything about the shift register only having 8 inputs. You can have as many as you want, which is how a oh my god, the word is escaping me, but a multiplayer, like a multi-tap kind of situation works. It's just it clocks in more. If it detects that you have a multi-tap, it clocks in more bits from all of the controllers. In this case, we are going to functionally, if you are familiar with keyboard matrix scanning, which is also what we're about to do in Python, to diagnose this poor keyboard and see what keys are dead, and if I care about any of them. You've got, like, so along one side here, a few of the pins go into one side, a few of the pins go into the other side, and then each key connects 2 of those lines. So you basically, ground or raise, whatever your active level is, you can scan the row or you can scan the column, whichever way you want to do, but one side is input, one side is output, and you assert one line and then read the outputs on the other side, and if any of those keys are pressed, that ground or active signal will flow through that key and out into the corresponding input on the other side, so that's how you can tell there's a key pressed. For the NES, and apparently this is how the official Famicom Basic keyboard worked as well, which was pretty redeeming because I figured this out before I looked up the Famicom keyboard operation. It works a little bit nicer than mine is going to, because the Famicom has some extra outputs that I do not have on a North American NES. But basically it kind of treats each row like a controller, so it clocks in, I don't know, maybe if one side, like for this one, let's say 1, 2, 3, 4, 5, 6. So we like clock in 6 bytes or 6 bits, and then after you've clocked in 6 bits, the circuitry will automatically assert the next column of the keyboard matrix, and then you clock in the next 6 as if they were, controller buttons, and you keep doing that until it cycles around. And I'm going to need to do some trickery, at least so the NES knows which row it's on, but that's about it. Lola says, so you have 8 keys / bits, so if you're using the Pico to translate it, you can basically set it to the bits to ASCII so the NES won't have to work to decode them as much. No. We're gonna scan the keyboard matrix. We're gonna clock them in. I guess we will know, like if you're on the first column and you clock in the first bit, that's the, / key or whatever is on there. But we'll basically have a software routine to translate what button was pressed into ASCII, which Basic then has a routine for wait till the keyboard has pressed an ASCII character and then give me an ASCII character. So we will have software on the NES that will read through the keyboard matrix, figure out what keys are pressed down, and then return what the ASCII value of that key is. So yes, no, kind of, sort of. What I'm just using the Pico for here is just to make a really quick keyboard scanning setup so that I can scan this matrix and see if I have dead keys where I've cut traces in the past. Then we will hook it up to the real hardware that I'm going to build that will actually interface with the NES. So yes, funny. I believe I should already have MicroPython installed on this RP2040 Raspberry Pi Pico. So I should just need Funny. Yes, cool. I love GitHub. I love projects supporting, you know, having easily accessible GitHub pages. Whatever happened to just having a download link, man? Is it down at the bottom? Where are the binaries? There they are. I guess I'm just not used to seeing a release page this zoomed in as well. But, like, if you click the download for Windows link, why can't it not just link to the... Anyway, this is me being an annoying old man. Let's go with the EXE. And BRB, I need to find a USB cable. Let's see if this pretty pink number is actually something more than a charging cable. And Lala said, that makes sense. Also, it would be funny if keyboard would have more processing power than the computer itself. Yeah, that's kind of part of the reason that I don't actually want to use a microcontroller. Again, it's like, it's totally aesthetic. It's not, like, a real engineering choice. It's just... yeah, exactly that. To me... I mean, this is all a ridiculous project. I can do whatever I wanted, but, like, seems more fun to do it with, like, actual hardware than to run a little software, and it just feels like an easy out. And, yeah, exactly. It would be funny if the keyboard had more processing power than the NES. That would feel weird to me. Okay, here comes the boring part where I install Sunny. And I just plugged in the Pi Pico, so hopefully that will just work. Let's get some coffee while we're waiting. And some sangria. Come on. Come on. You can do it. I believe in you. Compiling standard library. You always gotta love a step in the installation process that doesn't actually affect the progress bar at all. There we go. Come on, Thani. If everything is right, if I'm very lucky. When Thani starts up, it should just be working, and MicroPython should be on there. Let's see, I have to change some settings, and hopefully maybe figure out how to zoom in on the screen for you a little bit, but, oh, support Ukraine button, very nice. Options. Interpretor. MicroPython, or Raspberry Pi Pico, try to detect automatically, sure. There we go. Yay! It's already on there. So, what did we say? Well, let's, so what you're about to see also is that I'm a shit Python programmer. So, sorry in advance to anybody who's actually half decent at Python. Let me get my hair out of my way so I can think better. Which, of course, is a marginal improvement. Okay, so let me just start with machine. Actually, seriously, is there a way for me to... You know what I should just do? Why have I not been doing this? I should just up my whole screen DPI. Windows 10 settings suck. Personalization? Maybe? Nope. Displays? I totally know what I'm doing, guys. I'm a super cool professional programmer and stuff. Display. Let's scale it to 175. Is that the best you can do? That will work. That'll totally do. Ooh. Okay, that looks. I think that looks better in the screen than it does in the stream than it does on my screen. Because boy, the scaling does not look good on my screen. But anyway, plowing ahead. If I remember what I'm doing, from machine import pin. Running kind of slow. But let's see. Let's call it pin 8. And pin 8 should be GPIO 7. That should be that easy. Nope, there is no new in Python. And I think it's just pin the GPIO number, so 7, and then pin dot out. Doesn't really matter which side I pick for out right now, but I just want to make sure my queue works. And then we'll call this pin 10 equals pin 9, pin in, and yeah. Whatever, let's just plow forward with this. Pin 10 dot high? Sure. Pin 8 dot value? Pin 8 dot value. And then if we press the Q key, and it still does nothing. Neat. Let me exercise the Q key a couple times, but that is probably just the way it is. I am probably effing up something super bad. Nope. Still jank. What did I do? What did I do? Oh, pin 8 was my... Pin 8 is my out. Pin 8 dot high. Pin 10 dot value. Now let's press Q, and that should go to a 1. Ah, I should also probably remove the main program on here, but yay, look, it's a 1. It does a thing. Now it's a 0, I've stopped pressing. Now it should be a 1. Okay, yeah. Let's, for starters, delete main.py off of this, which is some old crap that I do not want. Or just load it, I guess. Sure. And really all I want is the pins, and delete all of this very important stuff. And I want to just make a loop. Let's see. Let's look at this matrix. Let's look at this matrix. Wow, now this is zoomed in, that is. Double zoom. Okay. Looking at this matrix. Or I'm going to label these by rows. Or, yeah, let's start with columns. So this pin 7 is, we'll call that column. Should we call this column 1 or that column 1? 1, 2, 3, 4, 5, 6, 7, 8. Let us call this column 7. Pin 7 is column 7. So 7 equals pin, and that was pin 7, which is one less on the GPIOs. And let's make this side our outputs, so pin dot out. And I'm sure there's some cool way that I could just like declare this all as a matrix. There totally is, isn't there? Shoot. Shoot, shoot, shoot. Dang it, I wish I was better with Python. I'm too much of a programmer. This is very annoying because I just want to like make like an enumeration of my pin numbers and then run them through, you know, a map that just maps them to new pin objects. Let's brute force this. Don't worry about it. Don't worry about it. Don't worry about it. Do it the easy way. Though, actually, let's go somewhere in between, because it would be nice just to be able to iterate over these. So, I don't remember my array literal syntax in Python. Oh boy. Is it curly braces? Let's break down. Let's break down and do the Google search. Python array literal. Sure. Okay, it is square brackets. Nope, I am not in by. Okay, and we are actually, that's going to be our last column. We're calling that column 7, so that will be our last one. Very good. And I hate white space languages. Well, hate is a strong word, but I do not thrive in them. So let's work from the, I guess from the 0 side. So, if this is pin 7, this is 6. Column 0 is pin 5, which is GPIO 4. And so on and so forth. Column 1 is, let's see, so if we said that was 6, or wait, no, we said that was 5, because this is 7, 6, 5. This is 4, which is GPIO 3. Hopefully it stays fairly regular so I don't screw it up too bad. Then column 2, yeah, no, of course it won't, is pin 1, which is GPIO 0. And 3 is 2, which is 1. 4 is way up here. Okay, let's see. 15, 14, 13, 10. Wait, no. 15, 14, 13, 12, 11, because I can count. Let's do that one more time. 15, 14, 13, 12, 11. The Ritalin has not kicked in properly today. 11, which is GPIO 10. Pin out. So that was, we were on 0, 1, 2, 3, 4. So we're on 5, 0, 1, 2, 3, 4. 5 is on pin 3, which is GPIO 2. And then the next one is, this was 11, then this is 10. Pin 10, pin dot out. Oh god, did I screw that up? If this was 11, this is 10, making it GPIO 9. And is that all of them? 0, 1, 2, 3, 4, 5, 6, 7. That is all of them. Cool. So that's all of our column pins. And then our row pins are going to be declared similarly. Thankfully, there are a little fewer of them, so this will be pin whatever, and it'll be pin in. So, let's start. I'm going to have the top, so slash will be 0, 0 in this matrix. So, And I'm going to ignore alpha lock. It's this weird little guy over here, and I'm just going to ignore it. Okay, so if this was 10, 9, 8, which is GPIO 7, pin.in. Next one is 15, 14, 13, which is GPIO 12. Next one is 14, which is GPIO 13. Then, thank you for staying somewhat regular, it's 15, which is 14. In. Then, where were we? Here. This guy is all the way up to, this was 11, 10, 9, which is going to make it pin 8. And wow, we are all the way at the end already. This is going to be 15, 14, 13, 12, which will be 11. Does that seem reasonable to you? Not sure if it seems reasonable to me, but let's just rip through this bad boy. What I'm going to do is just make a infinite loop while true, and then, well, first let's initialize all of our, not in Vim. Nothing like typing KKK every time you think you're in Vim. It's, embarrassing is not quite the word. Right, let us initialize. Let's just do for, I don't need to initialize our rows, but we do need to initialize our columns. For, let's call it curcol in calls, curcol dot low. I'll do these active high, because it looked like that's what worked for the one key, and why not? And let us, yeah, so I should just be able to do for my internet's been crap. Hello again. My internet's been crap since I got back home, so I was expecting some roughness. Fingers crossed we don't get too many disconnections. Anyway, so we'll just loop through all of the columns, and for each one we will just turn on, raise the current column pin high, and then we will loop through for cur row in rows, and then if cur row, I really didn't think of a good way to, well, I guess I don't need to know what key was pressed. I just need to know if I press a key down, it should print something. And if it doesn't print something, then that key doesn't work. So I don't care. So let's just print key down. Sure, that's fine. Oh wait, what am I doing? If cur row dot value, that might automatically like get auto dereferenced straight to value, but anyway, Python. So let me do one of those. And finally, is that it? Is that literally it? I think that's literally it. Yeah. Oh, I should lower this pin when I'm done. Cur call dot low. And that's it. It's just going to loop through each of the column pins and turn them on, then check all of the row pins, and if any of them is high, then we know a key has been pressed because it connected the two together, and bada bing, bada boom, if they were connected, the value of that row will be 1, and we will print key down. After we have checked that for all the rows, we will then deassert the column, and move on to the next column. And then when we've run through all the columns, we just start over at the top. It should be that straightforward, I think. I do believe. Cool. Name calls isn't defined. Of course it isn't, because it's just called call. Same for rows. Save it. Run it. Okay, cool. I can't type. This is call. Save it. Run it. And cool. Fun, fun, fun. So for some reason it thinks that there is a key always pressed down. That is fun. Fun, fun. Very fun. Okay. Let us do this. For call IDX in, we have 8 columns. Do you just do, oh, me and Python, can you just do this? Does that work? I think it's like this. You say your start and how many you want. We'll find out. And then just switch this to call IDX, and same thing for rows. We have what, 6 rows? 1, 2, 3, 4, 5, 6. Cool. 4 row IDX. Just throwing idiomatic Python right in the garbage. 0, 2. Because I think that's how range works. I think it's, you say what your starting value is and then how many. But we'll see. Because it will throw me an exception real fast if that's not true. So if row IDX dot value, then I'm going to print the row and column that it detected. There we go. So row, or no, let's go column IDX, row IDX. So now it should at least actually tell me which key it is triggering on. Okay, will that work? Will it run? Do I know what I'm doing? Okay, what is that 2-2? So 2-2 is column 2, row 2. It's saying the I key is always pressed down. Really? Really? Interesting. It definitely does stuff when I press keys. That's fun. Very all over the place, huh? Oh, I wonder if it's just because I'm scanning way too fast. That is fascinating. And I don't know whether it's pull-ups or pull-downs on here, so that could be part of it. Hey, Trempsy. Trempsy? Hey, Trey Dempsey. Sup, nerds, indeed. Okay. Let's just try reversing this really quick and see if it clears anything up, and if it doesn't, then don't worry about it. So if, let's make this if it equals 1, and yeah, so we're going to start with all of them being high, and then we will bring the line low. Sorry, if it equals 0, then we know that line is being pulled low. Cool, and then, oh, then I have to friggin' stop this because it's in an infinite loop. And there we are. Just making sure I'm not doing anything insane or missing anything. Oh, right, so let's slow it down just a touch. So from, I think it's system, import time? Yes? Maybe? Oh, missed this too. Bring it back high now. Sleep MS1. I'm sure that is totally not right. Yeah. No module named system. Let me remember where the heck time comes from. As a Python dumbass. Python time module. It is in the... Will you tell me what module it is from? Or is it just import time? It's probably just import time. That's probably the name of the module, eh? Yeah. Import time? And... I believe it's probably like sleep underscore ms or something. Sleep ms. No. This might be a MicroPython thing. MicroPython sleep milliseconds. Okay, so apparently it is a MicroPython thing, but it's also in the time module. Whatever. Save it. Run it. Sleep MS not defined? Is that what you're telling me? And it is MicroPython on here, right? It's not Circuit Python? No, I'm pretty sure it's MicroPython. Is it from OS? Oh, do I have to qualify it? Yeah, I think I do. Time.sleepms. Sorry, everyone who uses Python all the time. There we go. That seems better. So, hopefully that's just a spurious thing. Let's find out. Let's press a random key. Oh! Yeah, it really doesn't like me touching anything. Let's just gently turn this over. I really should have set up a camera and monitor at the same thing, but... And apparently it's just taking a crap. What? I mean, you'd think I'm going slow enough that I really wouldn't need to debounce the keys. I'm not trying to catch, like, individual key presses here. I'm just trying to see if a key is pressed at all. Which kind of seems to be sort of working. So, like, I am definitely getting spurious crap. Which could potentially still be because I'm flipping through the matrix too fast, but that doesn't seem right. But like you can see, when I hold down A, it's pretty reliably, well, you can't see my keyboard hand, but my keyboard hand is pressing A right now, and it reliably shows 5-0 there, which I feel pretty confident is A. Let us look at our matrix. 0, 1, 2, 3, 4, 5, 0. Yep. So that's right. 5-0 is A. whatever that 2-1 is spurious. So at least I think I can get away with this, because as long as I check that the key matches what I'm holding down, then I can double check which one seems to not be working. And that should be good enough. So, quite. I guess let's just start pressing keys and seeing what happens. So, starting with slash nothing. Slash appears to be dead. Is it everything? Because now I'm trying semicolon. So possibly everything on this row might be... No, but A worked. So, weird. So, maybe just these keys on that column. I should really be like screenshotting this and marking which ones up here to be broken, but P, dead. 0, nothing. Z, nothing. Interesting that they just have function and 9 over here, like they didn't figure out where those are. Okay. But yeah, A works. So maybe that's the last key that I fixed on there. Q works. 1 not work. Maybe I should just be marking keys good. Here, let's just go ahead and screenshot this shit. So I can do my lazy mode of marking broken things. So what did we say? It looked like all of... Let's find a good color. So this one broke, 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 this one. A and Q worked, right? A works, Q works. 1 did not work. Broke. All right, next row. What is that? Greater than? Broke. I mean, it's not surprising that a whole bunch of them seem to just be straight up broke, because, I mean, some like entire rows are slashed on this board. L? That looked right. That did a thing, right? Yeah. L is good. O is good. 9. No good. X. No good. S. No good. W is good. 2 is good. All right. Less than. No good. Just kind of exercising them too, because some of these keys are just like filled with crud. K appears to work. Is that right? That should be 2-1 or 1-2. Yep, K is cool. I. Wait. Yes, that is I. L is. Wait. K was 1-2. Or yes, 1-2. L is 1-1. Wait, that's not. Is that L? No, this is L. But L does seem to. Is L working? Am I losing my mind? Okay, K is column 1, row. K works. Column 1, row 2. L should be. Okay, so it's saying column 1, row 1, which is what L would be, and L worked. Okay, yes, I'm just going crazy. So I is column 2, row 2, and that also appears to work. Woo! Okay, sorry. 8, be broken. C, B broken. D, B broken. E, B broken. 3, broken. M, broken. J, broken. U, working. 7, broken. V, working. F, broken. R, working. 4, working. N, broken. Yeah, it looks like this whole row is messed up. H, working. Y, working. 6, broken. B, working. G, broken. Touch point span. They are fiddly. T is working. 5 is working. Plus is totes working. Space is totes working. Enter is super duper working, y'all. Int 6 and int 10. I do not know what those are supposed to be. I do not know. Will we need to come back to those? Let's see. 5, 5. Which would be, that would be the, whatever this int 10 is. Sorry, you're not seeing the key I'm pressing down, and I already forgot what it was too, but, so this is column 0, column 1, column 2, column 3, column, no, that's column 4. And, but this would be row 5. Row 0, 1, 2, 3, 4, 5. So anything row 5 is going to be these guys. And 5, 5, oh, that would be shift 2, which is, in fact, what I was holding down. Shift works. Nice. Control? Control is on there, and it's 6, 5. So that works. Function. Is it? I don't know. What? Oh. Those aren't key labels, like int 6, int 10. That's, I see. That's the name of the pin. So, yeah, they've got function 2 on here, but they don't have not function 2. Is there a different function key? I don't see one. But there are 2 shift keys, and they both register as 5, 5. So, whatever int 6 and int 10 are, I do not know. But that's, I think, all the keys. I don't think we're missing anything. As you can see, it would appear that a whole bunch of them are busted, but a lot of those should be relatively straightforward fix because they're like whole wires that are cut. And when I restore them, it will restore a bunch of keys. So, for starters, let's switch back to the overhead for you guys. And we can actually focus on the ones that are broken and then test them again and make sure it's actually working before I try and build hardware around it that, you know, may or may not work. All right, so let's just start from the start. So slash is, they are, things are written on the back of the keyboard. I don't know if you can see that, like, oh, these ones you can see right there. Those are key names. It's hard to make out. But so that should be helpful. Where is slash? It is over here. Yeah. So these pins are slash. So let us look at why slash would not be working. And it looks like almost everything on that row is not working. Which row is that? So that includes greater than, less than, mn equals, yes, okay. So, yes, that trace comes out here, goes around here, and gets cut in what appears to be several places. So I think if we connect this side of the slash to, what's the next, let's see, what is the next key in this guy? Let's point at it with a screwdriver so that I can see. Oh, also, I should turn my soldering iron back on. Let us point at it with a probe, because my eyes are fucking awful. Okay, that goes to a jumper. That is fun. But thankfully, I've already got my multimeter on ohms mode, so... Wait. Why do these both show up as connected? Well, what are you doing to me? Oh, I think... Okay, interesting. You probably can't see this very well, but there's a jumper wire that goes from here, and it goes from here to here, and then it goes from here to here. I chose the weirdest line to trace. No, that's bizarre, because... The hell? This goes to shift. Shift is not shared with either of the... What is going on? Am I losing my damn mind? Slash is here. This is the matrix line that I'm trying to look at. I'm just going to ignore the shift for right now, because this is greater than, which is on that same matrix line. So these appear to be connected, but it might just be because I'm insane. Yeah, these ones are. Definitely. Anyway, so let us connect here to here, and then this is where a whole bunch of the damage is, so we'll connect here to here, and the next one would be M, which is also screwed up and on the same thing, but that should also give us N. And you know, I wonder, a bunch of these, you think I can just fix them with solder blobs? I'm thinking that might be faster if I can pull it off. That's an idea, but I need to find a good scraping tool. Then I don't have to run big old wires, I just have to kind of jump some of these cuts. Let's try one and see how bad of a theory that is. Okay, so there's a big old gash right there, and that is why nothing is getting to the greater than key. Thankfully, this is early 80s shit, so the solder mask comes off super easy. Okay, so I have a bunch of exposed copper. Let's see if I can get a solder ball to bridge that. Well, this seems promising-ish. Ish. Come on, you can do it. I believe in you. I believe in you. You can do it, bro. Come on now. It's just sticking to the frickin' pin on the key. Please just bridge across. You can do it, I promise. Come on, man. This is the plan. Just go fucking across. Oh, it really doesn't want to do it. That is a bummer. Alright, never mind. At least I tried. Now I have solder wick so I can clean it up. Always clean up after yourself. My mother always said. This is the only place where I listen, but at least I listen. Alright, tiny bits of wire all over the place. Let's do it. Go from, I guess, just here to here. Tiny pieces of tiny wire, very fun to deal with. Thankfully, I have done this a lot. I've got a technique down. And tack on one side. And man, that is still hot. As I said, tack on one side. Tack on the other side. Done. Okay, so that gets us from slash to greater than. Let's go from greater than to less than. This poor keyboard. Had I known I would need a keyboard, I would not have done this to you, poor keyboard. But lo, here we are. Tack it on. Cool it down. Make a nasty crisscross of wires all over town. Hook it up. Okay, that should be less than. Now we need to go from less than to M. Which is right next door. Yet again, would be a very convenient, let's just do a little solder bridge. But no. I don't dare risk it again. Yeah, this is basically impossible to do if you don't have long nails. So thankfully I haven't clipped in a while, but pulling those little pieces of wire through that's what is it called? Wire wrapping wire. This wire wrapping stripping tool. Like, you can't get any grip on a wire unless you just pinch the crap out of it with your nails. So, I am blessed on this day for having long nails at the moment. Okay. think that's a successful connection, so we should be through to M. N looks fine. And I think that's the end of this row, yeah. So that should be, well, not everything in that column, but let's see, that should have fixed a bunch of stuff in that column, hopefully. Let us test. All right. So that will be, let's start with slash. Is that working? Is that functional? Am I reading it correctly? You are all over the place, Mr. Keyboard. Please just do what I wish you to do. What's that 5-1? 5, column 5, 0, 1, 2, 3, 4, 5. 1 is the S key. I'm just going to restart this thing real quick. It's going insane. Okay, now that you are settled down on whatever 2-1 is, which I am ignoring, slash seems to still be broken. Okay. What about greater than, less than? Okay, less than seems to work. I guess I can mark that. Fixed. Let's make that a little less ostentatious. Fixed. M. M works. Fixed. And N should work too, because N looked just fine. N. Yep. N works just fine. Fixed. So, slash and greater than are probably on rows that are screwed up. So, let's move on. Well, hell, let's just look at the row that slash is on. Slash is still over here, and it's row. Let's see, so it's shared with 0. 0 doesn't work, like almost nothing in that row works. So it's probably cut somewhere fairly early on here. So tracing it backwards. It's shared with enter? Really? What? No, that can't be right. No, I think that's semicolon. Which it is shared with. Okay. Trace it back, trace it back, trace it back. Looks like it could be potentially cut here. Might want to check that. I guess it doesn't matter if I just run a wire right between them. What's the... Let's see. So that was... You can't see this, but it goes through semicolon, then it goes through... Okay, so semicolon is the last one, so... Slash semicolon, next one would be P if these are laid out. It looks like they have been laid out, like, in the order they show up on this board, which is nice. I don't know how that's possible. Let's not worry about it right now. Where is P? Let's see if that holds up. P is way over here. Oh, P was already on here. Dang. And P also didn't work, which makes sense. It's over by slash. Okay, let's go back to tracing. It's that I have terrible eyes, and there are a bunch of these traces join up together very close at the bottom here, and I am having trouble following them. Down, around. I keep losing it. ADHD, not good. for this kind of work, man. Okay. Stay on target. Lost it. Okay, let's just count down. When we get here, it is the second one down, then it becomes the third one down, then it becomes the fourth one down, third one down, second one down. Oh, okay. And this is Z, I think? Yes, Z is on that row. I'm not crazy. I managed to trace it. Yay! Alright, let's see if there's continuity between Z and semicolon, I suppose. And there is not. Yes, I am not crazy. It looks like there is no continuity. And presumably there's supposed to be. So I guess that needs fixing. And then it looks like there are some cuts around where A and Q are too, so that makes sense. A and Q are probably like the first two things on the chain, and then it cuts off right after one. Makes sense. So let us start, just because I'm right here, bridging, I guess, from semicolon to Z. That's a big gross one, but I'm gonna do it. Semicolon to Z. Semicolon. It's so much easier to destroy than create. Which is just the bitterest irony when you are the one who did the destroying, and now you're the one who has to do the creating. Oh well, we just need this to work. And I don't have any other nice, this workable keyboards sitting around with a nice accessible matrix. So, 'tis what it is. Make sure I'm grabbing it at the right spot. Yes, this side of Z. And I seem to be doing good with not needing to put fresh solder on here, which is frankly kind of surprising. And oh, did I make it too short? No, I usually overcompensate in the long direction. Damn. We can deal with this, surely. I mean, I could just cut another wire. But that feels like defeat. Let's run it over here and we'll just connect it. I mean, this thing's already gross. F it. Just F it. We will connect it to the trace. Doody-doody-doo. Where'd my knife go? Here'd my knife go. It comes around here. It goes down here. Let's clear it here. And there you are. So yeah, I guess I can talk while I'm doing this semi-boring. I mean, you know, it can be meditative watching someone doing a soldering project, I suppose. But, you know, it could be like making conversation. VCF Midwest. That is happening. Weekend of September 11th, which, if I check my calendar, is... Yeah, that is like exactly 2 weeks away. Exactly. I got a booth. I'm gonna bring this thing there. And as you can see, I'm already taking, let's see, we've been going for an hour and a half fixing this stupid keyboard that I fucked up. That is what it is. So we're definitely not going to have basic running on this thing. So I need some voltage as to, well, there's really two directions that I think I could go. One is, I kind of already discussed it a little bit. I can just connect a UART up to this thing, connect the UART up to some kind of host computer, and have like a Linux terminal on an NES or something. Could be fun. Could be fun. The other option in the next 2 weeks, which realistically, okay, so I'll definitely get the like solder work to fix the keys on here done today, and hopefully, I really want to. I have a fair amount of time today. Yeah, I can go until 8, so this will be a nice long weekend stream. But I should. Oh, so I feel pretty confident I can get the keyboard input whacked out by the end of this week. So that leaves me a week to do something interesting, put on a UART or something. I also have a board with a pretty much hooked up floppy disk controller. That feels more interesting but more dangerous because it's way easier to, hook up a UART than to... it's about as easy to hook up the UART and the floppy disk controller. They both just have basically an 8-bit data interface and a couple of select wires to select registers in them. It's the software. It's going to take a little more software to drive the floppy disk controller, write like some kind of file system for it. I mean, I guess I could keep it real easy, but like being able to jam a floppy disk in there and see something happen would be neat. But also, is that as interesting as, being able to sit down and like interact with Linux or something from an NES? I don't know. So there's the vote. Should we go... I'll keep this open for this next week, but should we go UART to a laptop or something, or hook up a floppy disk to this thing? What should I try and get done for VCF? There you go. Anyway, let's get back to this. So we've got things hooked through to Z, which might fix up a bunch of stuff. I kind of don't see why A should have worked in the first place. Looks like one side of it, at least, is effed up, bro. Oh, but that side actually, it's all the stuff downstream of that. I see. But, let's see. So, A, Q, and what else was on there? 1. And 1 might be messed up because of its column rather than its row. So let's check out some more keys on that 0 column, or 0 row. See how much I fixed. Trey Dempsey says, I'm down to help. Trey, are you going to be at VCF? Or just, you mean like with figuring out the software? Yeah, Trey says floppy. I'm feeling the floppy too. It's just one of those things where it's like work versus reward, Trey says, yeah, I'll be there. Hell yeah, man. It was one of those, I'm so looking forward to next VCF because, like, I didn't know anybody prior to going there. And then people stopped by and they were just like, hey, cool shit, I saw your YouTube channel. And I was like, really? Really? And met people, so very much looking forward to that again. So I'll see you there, Trey. And like last time, I didn't quite have the VAX mouse and keyboard interface working by the time I got there. The software was still a little bit off. So I got there Friday night, and then me and a cool guy who I hung out with all weekend, and now I'm forgetting his name. I am so sorry. I don't know if you watch my videos. Real bummer. He wrote some software that I used. It was very cool. That was another one of those things where I ran into him, and he was like, oh yeah, I wrote some code to do that. And then we looked it up, and I had used his code. It was amazing. Anyway, me and him worked Friday night through to like midnight to get it semi-working. And then, like 5 people played with it, but it was, getting it to work was more fun than anything else. So if we end up in that kind of situation, I look very much forward to it. Okay, so we're testing the 0 row. Let's see. Slash is working. Fixed. Yes. Boom. Okay, I feel pretty confident about this row. 1 will probably still not work, but semicolon is doing something. Sure is. P. It's 2, 0. Yeah, that's working. 0 is, or is that O? Oh, that's 0. Still broke, but it looks like a lot of stuff on that column is broken, so that's not surprising. Z still broken, apparently. And 1 still broken, not surprised by that. A is doing stuff. Q is still doing stuff. Let me just double check these, because these keys are dirty. Yeah, no. 0 is definitely dead. Z is definitely dead. 1 is definitely dead. Okay, let me choose another column to work on. Let us pick... column 3 looks really bad. That's the one that 0 is on. It's this guy. Lots of red. Lots of red through here. So let me look at 0 and what connects there. Trey says, I used to live in Chicago. Looking forward to going back for a visit. Yeah, the Chicagoland area is pretty interesting. I have, I'm a Michigan native, so I have been to Chicago many a time. Had my bachelor party in Chicago. And it's a cool place. But it's also like, the metro is so freaking big. And I have not seen much of the metro, but it's just so much sprawl. Like vibes of LA, you know what I mean? It's kind of funny, because like, having lived in New York for a while, New York has sprawl, but it's not like Chicago sprawl. Like, Chicago sprawl is it's like, Chicago downtown, super urban, and then it kind of spreads out, but it still stays pretty urban, like lots of row homes, for quite a ways before it like finally drops off into the burbs. And then New York is like super dense, but I feel like it drops off into the burbs real fast when you get out of the city. Anyway, I just love to explore more of the Chicagoland area, because VCF isn't in Chicago. It's in whatever adjacent town. And I've never been to Texas, so I actually would love to see, like, Houston, the Dallas-Fort Worth area, I understand is supposed to be ridiculous. I can't talk and solder at the same time, it turns out. Oh, no, 0. We're looking for 0. And we are looking for the one that it shares with 9. So let's see. 9 is over here. Let's see. Not this one, that's the one it shares with P, which is, so that's the row. So it's got to be the other one, which, yes, is shared with 9. So, that surely must come from, yeah, that loops all the way around here to the left and goes over to the other side of the board. So, let's see. Similar tracing story, let's see. Okay, it is the third one down, fourth one down, Fifth one down. Fourth one down. Third one down. And yes, it goes into this messed up corner where our 1 is. Yeah, it's messed up. It is messed up. But I think if we just connect... 1 is not on there. What is on there? Well, it kind of gets cut like this whole row is cut. It's cut like right before it goes back to the header. So what if we just reverse the curse and connect 6, which is over here, to the actual pin it's supposed to go to, and then it's only that far apart, and bing bang boom. Trey says, yeah, VCF is in BFE. But see, this is the thing. I wouldn't know. I mean, it's fairly clear that it's BFE, but I'm not from there. Cool. Yes. We will just connect this whole row or column or whatever the hell it is from the other side. And I'd love to have the time to make an enclosure for this keyboard, because like whipping something out of plywood really shouldn't be that hard. But I also don't have a lot of tools for, you know, that kind of work. Like it would be nice to have like I don't have a jigsaw handy. Could probably steal one from my dad. But yeah, that would steal precious time. And it's way cooler if it's a janky piece of shit. So that's what I'm feeling. But someday we'll want to make a nice little enclosure for this keyboard after VCF. Okay, that should fix once this freaking solder melts, because old solder. Though I'm surprised that I've been having relatively good luck not like re-wetting most of this solder, which works just fine for my lazy ways. Yep. And I don't need like super great connections, so they just need to survive. All right, so that should like fix that whole freaking column. Let us see. All right, here we go. And we're back. Please, OBS, don't cover up what I'm trying to demonstrate here. Interesting. I think that made things better with the scanning. I wonder if there's a lot of false positives because of like partially cut lines and it doing weird things. Anyway, we are looking at, okay, so 0, yay, look, it works. 9, yay, look, it works. 8, totally works. 7, totally works. 6, totally works. And then God knows what that blank key is there. I mean, I guess they're just saying there's nothing hooked up there. Probably. I don't know. But these are all fixed. We are getting there. Bam. Blam. So, I guess let's move on to Z. Let's see why the Z's column is not working the best. Oh, I crack myself up. Z is hiding over here. It is hiding in this spot. Z's right here, and it's cut off from everything. There's so much damage around here. Let's see. Z is dead, X is dead, C is dead, and yeah, that follows from the damage I am seeing here. But I think if I just connect Z to X and X to C, will be repaired. Z to X is what I'll do. Hook it up, make it true. Literal crickets in the yard. Try doing this work, it's fucking hard. No, it's not that bad. But it rhymes. And if it rhymes, it's true. Oh, one of the other really nice things about working with this wire wrapping wire is that the insulation does not melt so easily. Which, when you're working with smallish things, and also alternatively when you are a not crack hand at things like I am, boy, it really helps, because when you bump the iron against the other wire, it doesn't melt it and give you a short. Nice benefit. Okay, that is Z to X, and now we just need to do X to C. Snip it, grip it, rip it, and ship it. And lose your wire. That is the downside of this wire. But man, it's so much easier to get routed around these boards. Hey Derek! Derek says, over a week of nothing and I catch you randomly over an hour and a half into the next stream of this. And he says, and like always, I've actually just been sitting around most of this afternoon. That is how it goes, but thanks for joining in. Good to have you. You haven't missed a ton. I mean, it's been pretty much an hour and a half of me, bringing this keyboard back to life, which we need to do before I can, attach it to anything. But we're getting there. I think I'm like, I was going to say halfway fixed, but like realistically, since I'm fixing like whole rows and columns at a time most of the time, maybe a third of the way fixed? Wait, no. 2/3 of the way fixed? I think I just said I'm worse than I was going to say, which was not my intention. I don't know. They taught me math wrong as a child. No, they didn't. They did a fine job. I just have a stupid brain. Anyway, we're well through it. We're doing good. Okay, that should have fixed a lot of stuff, hopefully. And yeah, I built this. I currently have the keyboard matrix plugged into a Pi Pico that is scanning the matrix and returning me garbage most of the time, but it's doing good enough that I can tell which keys are more or less working. So, let's see, I fixed the 0, so Z appears to be working. X appears to be, wait. X is not 4-2. X is 4-1. Yeah, C is 4-0. Uh-huh. Okay. C. Uh-oh, did I do something weird? Because C should be 4-2. Uh-oh. Well, V is also not right. Did they just... Okay, B is 4-4. Which is right, so I think I might just be going insane. B is 4, 0, 1, 2, or 0, 1, 2, 3, 4, 0, 1, 2... You can't see me pointing at my screen. Whoops. Oh well. 0, 1, 2, 3, 4. Yeah, so that's right. So B, 4, 3 is V, 4, 2 is nothing. 4, 2 is giving me X, but it's showing C on here. Fascinating. And then Z is 4, 0. So what the hell is C supposed to be? That is interesting. Is this wrong, or did I fuck up? I mean... Okay, it looks like there are potentially reasons that C would not be working besides this row, so... I think they just have those backwards. I think it's potentially C and X are just backwards. Let's cross our fingers on that one. Totally, totally possible. Because, yeah. Otherwise, that would make things work out. All right, so let's see. What did I fix? Z and X? Yes. Yes. B was already working. B was already working. Cool. So I guess let's work from C. Why not, right? And the C, let's work on the other, this row 2. That's what it is. Let's work on row 2 now. Row 2, which is the other side of the C key. And C is not working, so let me trace back where it is possibly broken, which is like definitely, it's cut right on either side of D. That would do it. And that goes back probably to F. No, E. Yes, because I can't read. Yeah, that would be the right one. E, and then 3. So yeah, it comes from the other side of the keyboard and then just gets completely fucked up. So let's connect C to D and D to E. And then, let's see, trace back the other way, because C doesn't work, so it's got to be cut before there too. And hold up, I definitely just traced that wrong. No, here we go. Nope, that is the column. And this goes back to, oh yeah, it is cut big time at less than. Okay, yeah, less than is wired up, but then it's cut after less than. And I had fixed that when I was doing less scrupulous fixing earlier. Is that right? Is that right? No, it's connected to greater than. Yes. No. Yeah. No. What? Did I do something weird last time? I think I did something weird last time. Sorry. Hold. Hold. Yeah, I connected some wrong shit, dude. Damn it. Huh. Yeah. I connected one side of less than to the wrong trace, I think. Yup. Fuck. Interesting. I think I can fix this all just by moving all of these wires to the left slightly. Because it connects to the wrong side of C, and then it also connects to the wrong side of D, and also connects to the wrong side of E, which are all of the ones that I'm trying to fix, so interesting. So I may have just re-broken some keys, that's fun. I mean, those shouldn't have really ever worked in the first place, so probably not. Let me get those tweezers. Undoing all of my previous work. But hey, if I hadn't done it this way, I would not have caught this. So that's good, right? So there's my defense for taking the time to make a little matrix scanning thing. Come on, old solder, melt, you bastard. You can do it, I believe in you. You just need to work, you don't need to be pretty. That's what my father always said to me. Oh man, these tweezers have gotten so effed up in the years that I have been using them. Sorry, buds. I'm going to need to buy a new pair. You have been troopers. But you can't grab wires, which is really kind of a crucial issue, I'm going to be honest. Okay, I think that's something. So, at the very least, that should have fixed C and maybe some other stuff, maybe. But also, you know, potentially rebroke some stuff. To the left, says Trey. Damn straight, Trey. C, yes. How do I keep bringing up this find and replace dialogue? Is it just because I'm stupid? Or is it because I'm stupid and also have bad hands? Okay, C. Very good. C would appear to work, which is, yes, column 4. Row 2, that tracks. Let's see, D. Still don't work, but I think shit was broken around D, so let's not worry about that. E is 6-2, so that's right. 3-7-2, that is right. Let me mark those before I forget, because I kind of almost did that for the last ones. So C did work. Yes. C worked, D didn't. E does, 3 does. And again, that's probably because all of this crap is screwed up over here. And let's make sure the rest of the stuff on this row still works. So let's check less than 0-2, yes. K, 1-2, yes. I, 2-2, yes. 8, 3-2, yes. And then the rest of these we already know worked. Cool. So it looks like I didn't break anything that wasn't already broken. Which brings me to D, F, and G. Oh my gosh. Oh my gosh. Okay, so the sorry, I was just surprised by I don't have that many keys left. Wow. Looks like greater than J, D, F, G, and 1. Unless I'm missing anything. Cool. All right, let's see about D, F, and G. And it only took me 2 hours, you know? Easy. So, D, F, and G. D, F, and G. D is hiding over here, and there's just a big old cut between D and F, so there you go. There's that. Let's just fix that. And then G is probably on the other side of F. Yes, it is. So this should fix all of that. Nice. Very good. Silence is when I am concentrating. That's when you know shit's getting serious. D2 F. I'm D2F. Don't know where I'm going with guess I'm D2F my wife. Very happily married, thank you. Okay, now DF and G. Oh, S. S also doesn't work. And there's a big cut between S and A, so that would also do that. So let's just fix that too. Right here. I mean, at least, is this still better than the episode where I was choosing characters out of the Super Mario Bros. 3 character realm? Because that was slow. It was like 2 hours to pick characters, and that was that entire stream. So, at least this part should be a notch above that. All right. A and S. As it were. And in the time that it took me to fix this keyboard, I could have just built a whole new keyboard. But, you know, I do this partially as, you know, punishment for something horrible that I have surely done in a past life. Okay. That should have killed a bunch of stuff. See, this find replace dialogue. What am I doing? What did I do? All right. Yeah, it's definitely getting less and less spurious key presses the more I fix stuff. Okay, so A should work. It always worked. 5-0, that is correct. S, which is what, 5-1. Still nothing. But we do have D. Okay, probably the other side of A is screwed up. So D is fixed. Come on. Come on, little mouse hand, you can do it. So D was fixed. F is also fixed. F is 5-3. Very good. G should also be fixed then. 5-4. Cool. Ignore the spurious bits. And let's go back to S then. So I think it's just greater than J, S, and 1 that we have to fix. Let's see if we can just knock those suckers out. Oh, you weren't looking at my screen. Just trust me. Just trust me. So 1 is all mangled up over there. Mangled would be the word. Let's start with S. Let's start with S, which is, yep, very clearly just cut off from everything else. Right here. Where can I tap into it? Looks like at W. Comes down around here and up around there, and yes, right there at W. Boom. Like this would be, like, even if I had just desoldered whole frickin' keys out of this board, still would have been easier on my future self than this. So, good going, I guess. Good going past me. You did it. You chose the most pain in the ass possible way. Which, you know, apparently that's like in my manifesto, so it tracks. I can't say that it doesn't track. All right, there's S, theoretically fixed. So let me just do them. Let's see what's going on around J. J is somewhere hiding here. Also just straight up cut off of the row or column or whatever the fuck that is on. So let's hook that back up. And that goes up to U. J and U are on the same row. Yes, they are. So there we are. There we are. And that will be J theoretically taken care of. And I'm so looking forward, you guys, to actually building the frickin' hardware to connect this to the NES. You have no idea. I guess I can start jabbering about it a little bit while I'm sitting here soldering. And my face keeps going off the camera, which I have noticed. Whoops. Sorry. You can't see my pretty face. Anyway, I'm thinking, because basically, you know, I'd need like a, make sure I'm connecting to the right side of U, sorry. I need a counter, not a counter. I guess like a, to step through the matrix lines, I need, I mean, I guess basically just like a shift register that's configured to just keep sending a single bit high through the whole thing. Which could be accomplished, I guess, because I don't know the easiest way to initialize that. Anyway, could also be accomplished with a binary counter and a demux. And yeah, I think that would be a demux. And then I would also need a, it's basically just that and a parallel in serial out shift register. Thing is, I don't have any of those parts. I have a bunch of 74 series crap, but nothing particularly that. But you know what I do have, as I try and get tucked back into this, is I got a bunch of gals. I don't know what they actually are. They're 16 V8s, 8 V16s. We'll get to them, but I am looking forward to using those, which is somewhat cheating with programmable hardware instead of just building the hardware by hand, but I think it's a nice happy medium. So there's your preview on what the plan is there, and that's why I'm also looking forward to it. Besides just, you know, building hardware is fun, we're going to do it with pals, and with pals as well. Pals and pals. Okay, what's going on with greater than? Greater than is over here. It is just in a real effed up situation. So I think this one also just needs to be directly connected to, looks like everything else in that row has mostly been fixed. That's the one that has S on it, which I think I repaired. Yeah, because I just directly wired S to W, and W was connected and working okay. So, what can I do here? What's the most straightforward way to connect to something that I know is working? Let me grab, if I go from here to, goes around to, what side are you on? I mean, I guess if I just go straight to S, I mean, why not? Why not? Another big ugly one, but it's one of the last. One of the last. Just gotta make sure I connect to the right side of S. Some foolish guy did everything to the right a little bit ago. Don't want a repeat of that. if this is the right pin. That should be greater than. Okay. We are tacked on at greater than. We are tacked on at S, but I have undone a solder joint at S, so let us fix that again. And hope we don't lose the other one that we just put on, which we just did. Cool. Cool, cool. This is working out ideally. Okay, that is now on a way where it should actually be springing into the pin and can't escape. The greatest plans of mice and men. Right, that should hopefully fix greater than, and then I think the only one that's left is the 1 key. And that is... in how many places is that screwed up? Let's see. Let's use the multimeter for this one to see which side is connected and which side is not. Because there's definitely a cut right here. Big old one right there. But can I get away with just fixing that side? Let's see. Let's see. So that is column. And does that connect to? Or I guess I could just check on one that works. I mean, okay, so it's obviously not connected to on that column. That's an easy check. That's the one that I would obviously need to fix. And then the row, let's see. Q on that row is theoretically working. Let me see. Yeah, and those look connected. So, or not. Yes, those are not connected. Cool. So one is just totally fucked. So I'll just connect Q to this, or yeah, this side to Q, and this side across to 2, and hopefully we have a fixed keyboard. Hopefully, maybe, hopefully. Assuming I did everything right, which is a big assumption. Because, you know, definitely a smart move to just fix a bunch of keys at the end here without checking anything in between. That always works great. You definitely won't lose track of things and screw things up in the interim. I promise you that. Okay, there's one side. And I did not even strip the side for the Q. Nicely done. Professional. If you can't tell, I'm not actually an electrical engineer. Let me just put my big fat forearm in the way of everything so you can't even see what's going on. What a great stream. Apparently, my 65816, well, the video on this old boy has really been blowing up, which is cool. And, you know, by really blowing up, you know, for a channel with a good, like, over, like, 2,300 viewers or something, it's cool. It's been popping. You know, it's like 50,000 views. Still pretty cool. Everybody seems to be... A lot of comments on how much they love the singing at the end. So I'm just gonna make these streams continue to be me humming to myself about various things, if that's okay. I haven't heard anybody complain so far. So I'm just gonna go with it. Okay. Why did I do that? That is not how you strip these. You have a tool for that. You are the tool for that. You tool. Good enough. Good enough. Oh, come on. Ooh. okay, I was going to say, don't make me regret trying to attach one end and then cut and strip the other end and then just like rip my previous solder joint out. But it all actually worked out. How about that? Come on, baby, you're the last one. You're the last joint. Say it with me. Good enough. All right, let's check to see if every key works now. Is my matrix still plugged in? Seems fine. Seems fine. And I am thinking, for heads up, just so that, because, you know, this is going to be a long stream. We're already at 2 hours. I'm going to split this up into the keyboard fix stream, and then I'll take a quick break and come back, and I'm going to start a second stream. Maybe I don't want to ramp up my numbers. Well, nobody said that an episode had to be one day. I could do two episodes today. I could do 17 and 18. But I'm, you know, just to split it up for people who are only interested in certain parts and don't want to watch the whole freaking keyboard soldering thing, which, good on you for hanging in there tight if you did. Really appreciate it. Anyway, gonna start a second stream for subsequent work on keyboard hardware and whatnot, just so you knows. All right, let's run this again, and we're looking for 170. That looks right. That looks right. S, right? S switch is still not doing anything. Cool. We will have to come back to that. But one is fixed. I can mark it. There we go. Thank you. One is fixed. Greater than. Are you fixed? No. And that was the one that was shared with S, so that was not good. Does J work? J works! Yay! Thank you, Jay. Thank you for sticking in there, bro. Just making sure that makes sense. Yeah, that's column 1. Yes, column 1. Row 3. Yes. J is good. But we still have a problem with S and greater than, which is probably because they're on the same line and there was something broken. I think I just connected greater than to S. No, it should be W is connected to S, and S is connected to greater than. So, what did I mess up there? Probably that it doesn't come from that side. But no, sure. Wait. Okay, so tracing this through. W is here. This is where I tacked on for W. And that has a branch going up to here to 2, which was working. But that is where it terminates, it would seem. So how is it? It's got to be like on the other side for these, but everything else on those rows is working. What? So the N, this, what is this? This is row 2. The row 2 trace terminates here at the 2 key. And then it comes down and it takes a brief visit to the W key, which well, I'll have to double check. I will have to double check if those are still working, because I didn't. So we'll just have to check everything on that row really quick. And then the W key takes, after the W key, it comes back down here and would go to the S key, but that's where it's cut. But I have soldered those together, so those are now reconnected. After the S key, it takes a trip down around over here. There is some cottage that, oh, well, huh? What? I'm gonna have to retest some keys. Because one side of X, which is what this one is right here, is just totally cut off from everything. And I have not reconnected it to anything. Even though I marked it as fixed. That's fun. I must have desoldered something from there. I think that's when I moved everything to the left, so actually, the way to fix that is, okay, so connected this wire. This wire here is going from greater than to, noting greater than, which still don't work, which makes, oh, hold up. Well, yeah, greater than looks like it's cut off in a bunch of places. So I really need to reconnect greater than to wherever it is supposed to be coming from. And is L? Yes, L is on there, and L is working. So maybe, hopefully, if I jump a wire from, like, I don't know why this ever seemed to be working in the first place. Again, probably because from when I moved those wires to the left. So let's go from L to greater than between these two, and then I've already got the one going from greater than to S, which take care of our reconnecting W and shit, but does not reconnect us to X. So I'll need one going to X as well. Then we shall retest the whole keyboard. Because what, S is like the only one, oh, S and greater than are the two ones that I'm working on right now are the only two that are not working right now. Let me make sure I'm not connecting to the wrong side here again. This comes around here, goes over here. Yes, I almost screwed that up. So it goes to this side of L, over to this mangled greater than. See, this is, as I have said before in my streams, this is getting stuff done. Like, this keyboard's totally effed. The only way to fix it is just to put in the frickin' hours. Which I should clarify, I personally am not necessarily very good at putting in the frickin' hours. Hence the streams. They're an entertaining way to get me to stick to putting in the hours. But if you want to do, like, building that, everybody's commented again on, because that video blew up, on the wiring on the back of the 65816 machine. That's not because I'm a genius. I mean, I think that, you know, most of you are, if you're watching the stream now, then, like, you're totally with me. I don't need to explain this to you, but it's not that I'm a genius that I made that bajillion wire wiring thingy. It's because I kept wiring shit together. And that's how you get to a bajillion wires. And then it looks very impressive, and people are like, how did you keep track of that? And you're like, because I had to. I didn't just, like, magically know where they go. I spent friggin' hours connecting wires, doing, like, let's do 32 wires, connect, like, some address and some data or something until your mind goes numb, and take a break. But you have something connected now. You managed to connect a peripheral. Except maybe the control signals. Oh, we'll do the control signals tomorrow. Until you're frickin' done with it. And that's how I built all the wiring on the back of that thing. And that is really not even that bad. Okay, so I connected L. The other one that I needed to do was S2X, yes. Which is a fun maneuver because I already have, let's not go. Just because I don't want more than 2 wires going off of these because it starts getting hairy to try and keep them all attached at the same time as you're heating up the joint. Let me go to, what else is connected this side of W was connected to... let's go all the way from 2 up over here. Up over in this corner over here. Back down to X. And yes, I totally could have just fixed this by looking at everything that was cut and just bridging a wire over it, which is more or less what I'm ending up doing, but with the keyboard scanning matrix, I know whether the key is working or not. That, and now this should be hopefully the final solder joint connecting the 2 key to the X key. If I am a lucky man, which I am... Actually, I feel like I was going to say which I am not, but I feel like there are many things I could self-deprecate about, but I've been pretty lucky. Pretty lucky in my life. Not gonna lie. Okie dokie. Find and replace dialogue. Good to see you again. Cool. Thanks for being my friend. Stop. Run. A bunch of false positive keys. Cool. Let's ignore those. Okay. Sorry. I didn't realize you were losing your mind. Hell? Okay, I am going to copy all this, kill Thani, unplug, replug, start Thani, oh, just drag this off screen. That's totally what I meant to do. No, don't do that either. Oh, actually, you know, that will work. Sure, yeah, cool. And paste this back in. Uh-oh. Uh-oh. But I saved it to the thing, right? Uh-oh. Uh-oh. Yes. Oh. Whew. Alright, let's check the broke keys. And that was greater than. Yay! S. Yay! And that was it, because like J we had already checked. And we do need to recheck the greater than row in general. So greater than, yay! L, yay! O, yay! 9, yay! X, yay! S, yay, W, yay, 2, yay. Okay, so just for, I think this is totes fixed, but just for, you know, good measure, let's start at the top left and just make sure every frickin' key is working. Because that way it is confirmed, and I know when I start building hardware around this thing, I'm not going to be like, oh no, my hardware is broken, or my software isn't working properly. I will know these keys actually frickin' work. So, slash, working, colon, working, key, working, 0, working, Z, working, A, working, Q, working, 1, working, greater than, working, L, working, O, working, 9, working, X, working, S, working, W, working, 2, working, less than, working, K, working, I, working, 8, working, C, working, D, working, E, working, 3, working, M, working, right? I wasn't looking. J, yes, M was working. J, working. U, working. 7, working. V, working. F, working. R, working. 4, working. N, working. H, working. Y, working. 6, working. B, working. G, working. T, working. 5, working. Plus, working. Space, working. Enter, working. Shift, working. Other shift, I think working. Yes, other shift working. Control, working. And function. Oh, function is not working. Fascinating. Let's double check function really quick. But otherwise, everything else looks great, so that's great. That's very good. That's very, very good. So prepare yourself for a quick break in a minute. Like, function looks like it's attached to everything just fine. Honestly. Really? You don't work? You look fine. You look absolutely fine. You're connected to things that definitely work. Yeah, you're connected to shift. Shift totes works. It's on the other side of function from there. Oh, whoops, I was totally tracing the wrong line. But it's connected to space. Space works. And it is connected to... alpha lock, which we were ignoring. Wait. Oh, wait. I gotta reset this thing. Whenever you wiggle the frickin' keyboard, it goes wild. But so if I try and do function, nothing. Alpha lock. Yeah. Does a whole bunch of things. Because alpha lock is weird. Oh, it might be things going through the alpha lock floating. That's causing a bunch of my problems. But yeah, it looks like the function key doesn't do anything unless the alpha lock key is engaged. Interesting. Well, I'm not going to worry about it right now. Because function otherwise looks hooked up properly. So whatever. Oh, that actually is... I am scanning the alpha lock key. I wasn't thinking about that. Because I just kind of... I jammed all the wires in here. I hooked all 15 of them up. And... alpha lock has a wire to itself, actually. So I am probably acting a little foolishly because I didn't know. I didn't quite get the way that alpha lock was hooked up. And I was going to just ignore it, but then I accidentally didn't just ignore it. Sorry, wrong screen. Yeah, so you see alpha lock is connected between this row, or this column, the one that 1, 2, 3, 4, 5 and function are on. And then the other side connects to its own pin. So, yes, that is weird. So I really just shouldn't be scanning that guy. And I didn't think I was, but also because it's floating, it's causing weird things. Whatever. I'm just gonna call this all fixed. I'm calling it all fixed. It works fine. It works great. We won't worry about the function key right now. After all my talk about being certain, I'm going back to good enough. Okay, so that's that. As I said, I'm going to take a quick break, and then I am going to start an actual totally second stream. So just keep an eye out. You know, just keep an eye on my channel in the next like, what time is it? 7:12. So that one won't be a long one because I need to quit at 8ish. So it might just be like a half-hour thingy. But I do want to start a little stream on building hardware. But keep an eye on my channel. Next 10-15 minutes, and we will have the intro to the next section. But I don't want to waste any time since VCF is coming up with great impendingness. So I need to get cracking and use all the time available to me. All right, I will see you there. For people who are just like watching this individual video, I mean, go to the next video. It's gonna be there. But also, peace. Thank you. Take care. Bye. See ya. Love ya. Bye.